Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So this is a continuation of IPRAN training series, and remember we have discussed different protocol that you need to deploy on IPRAN network. We discussed the IGP protocol using ISIS as our IGP, and we demonstrated how you need to design and even doing the configuration of ISIS on our IPRAN network to ensure that we have reachability. Then in our last two previous sessions, we have discussed how to deploy BGP on our IPRAN network. And given that we have BGP running on our network, we now need to start looking at how we will be deploying services on our network. Remember, the IPRAN network is used to carry different services. So we need one more technology that will be able to allow us to configure all these services that will be carrying on our network. That's why in this episode, we will be focusing on how to deploy MPLS on IPRAN network. So MPLS stands for multi-protocol label switching, and it's a very common networking technology that has been adopted in the past recent years, and it's widely deployed on service provider networks. So MPLS will be allowing us to deploy different services, whether enterprise or even the mobile services, the 2G, 3G, and 4G services on the existing network. So we have configured ISIS as our IGP for reachability between different nodes. We have configured BGP, which will be used to exchange routing information for the VPN routes. So now we are going ahead and deploying MPLS. So instead of doing the IP forwarding, we'll be doing the label switching on our network, which is much faster compared to the traditional IP forwarding. So this is the topology that we've been using. We have the aggregation nodes and the access nodes. So the aggregation nodes are in aggregation ring 1, where we are running ISIS process 100. And then we have access ring 2, which is running ISIS process 30. And remember, we have already performed route import between these different processes, and BGP is already configured and running on our topology. So the next step is now to deploy MPLS that will allow us to deploy both layer 2 and layer 3 services. And in our upcoming videos, we'll be looking at how to deploy these services on our IPRAN network. So for MPLS configurations, remember MPLS stands for multi-protocol label switching, and it allows us to run different protocols on the underlay network, same underlay network. So given that we have a service provider network that we are carrying different services, that's why we need to deploy MPLS on our network. So remember, on MPLS network, we have different nodes playing different roles. For example, we have the PE nodes, we have the CE, and we have the P nodes. So for service provider, the IPRAN network, it's the MPLS backbone of the network. So the CSGs, the ASGs, the RSGs will be acting as PEs depending on where the services are configured, or depending where the base stations or the customer are configured. But the CSGs, all the CSGs will be connecting to the BTS. So the CSGs will be acting like the PE nodes, the provider edge routers of the network. And then when a CSG is acting, for example, if CSG02 is the PE node, then it has to forward services to the RSG. The RSG will be connecting to the controller. So the RSG will also be acting at the PE. So the intermediate nodes can act as the P nodes, the provider nodes in the network. So the IPRAN network will be our MPLS backbone, as I've mentioned, and then the CSGs, the ASGs, the RSGs will be the PE, the provider edge nodes, the P nodes, depending on the service setup that will be configured based on the requirements. And then with that, we need to ensure that we have route exchange between different PEs. So the PE, the CSG will have to send routes from the BTS. Remember, the CSGs always connects to the base transceiver station. So they will have to advertise the routes, and then these routes will be learned by the RSGs. So we have the route exchange between the provider edge routers. So for the configuration steps, we need to perform below actions. The first action is we need to enable MPLS on all routers. So before you do any configurations for MPLS on the router, you always have to enable it on the router globally. So you enable MPLS globally, and then you can configure other functionalities of MPLS. So the first step will be to enable MPLS, and then you also need to enable MPLS and LDP on all interfaces. So LDP stands for Label Distribution Protocol, and the reason we are enabling it's because we need to ensure that labels are exchanged or labels are distributed on our IPRAN network from PE to the PE to the PE on the other end. So that's why we are using LDP. We are also enabling RSVP. Remember, LDP doesn't support traffic engineering. That's why in this lab, we'll also be enabling RSVP, Resource Reservation Protocol, so that we can do traffic engineering on our network. So you need to enable MPLS, LDP, and RSVP on all the interfaces. Another thing that we need to do is to enable BFD, the bidirectional forwarding detection, so that we can be able to detect when there are faults in the network. And then remember, LDP will have to establish sessions between nodes. So it's very quick to detect that a session is down or a link is down, then the LDP session will be teared down and avoid service impact. The last step will be verification, just to ensure that our MPLS, our LDP is working okay, and even the RSVP that we are deploying on our network. So for the configuration, I've already deployed the configuration, but we'll go through them step by step just to try and understand how it's configured on the routers. So given that we are enabling BFD, you also have to enable BFD globally. So that's why on all these nodes, you can see that the first step of configuration is to enable BFD globally before we can even enable it for MPLS or enable it on the interfaces. So this is always the first step when you are configuring BFD. Then the second step is to enable MPLS. And MPLS has what we call the LSR ID. This is like the router ID when we talk of OSPF or any other protocol or BGP. So MPLS, you also need to configure the LSR ID. And many times we use the loopback 0 as our LSR ID. So this is the first step when you need to enable MPLS on your router. You cannot enable MPLS without configuring the LSR ID. And the LSR ID should always be unique in the network to avoid any issues. So once you've configured the LSR ID, you need to enable MPLS. And then I've mentioned we are doing MPLS traffic engineering. So that's why we are configuring MPLS traffic engineering. And then you also need to enable RSVPTE so that we can do traffic engineering. We can be able to deploy tunnels, the dynamic tunnels on our network, just to enable traffic engineering on the network. Then we are also enabling BFD. So if we have any interface that we have configured RSVPTE, then we enable BFD on that interface. And then we are configuring the min RX, min TX, and RX for BFD for all the interfaces. And another thing that you need to enable is the RSVPTE hello, so that these two nodes will be able to exchange messages to detect the session status. So this is disabled by default, so you need to enable it using the command MPLS RSVPTE hello. Then you also need to enable the MPLS TE CSPF for the calculation of routes. So these are the commands that you need to run when you are configuring MPLS on the device. Then remember I mentioned that we'll be deploying layer 3 and layer 2 VPNs on our network. So you also need to enable MPLS layer 2 VPN on the network. Then you will be able to deploy the VBWS, VPLS, EVPN, because all those are layer 2 VPN. So you need to enable layer 2 VPNs MPLS before you can deploy such services on the network. And then we are using LDP for label distribution. So you need to enable MPLS LDP globally on the router. Once you've configured MPLS on the router, you now need to enable on the interfaces. So on each interconnecting interface between this router, the CSGs to the ASGs, ASGs to the ASGs, and ASGs to the RSGs, you need to enable MPLS and MPLS LDP. Those are the most important ones. MPLS and MPLS LDP on all the interfaces. If you miss on any interface, the services that you are deploying will fail to come up. So this is a very important stage and you need to do it with care. Remember, I've mentioned you are also enabling RSVP-TE, so you enable MPLS-TE, traffic engineering on the interface, and you also need to specify that you are using MPLS RSVP-TE and activate the RSVP-TE hello messages on the interface. So these are the configuration on RSG1. As you can see, we are just enabling MPLS on the interfaces, and MPLS LDP on the three interfaces connecting the ASGs and the RSG interconnect. So on RSG2, we are doing the same. We enable MPLS, MPLS TE, MPLS RSVP, MPLS Layer 2 VPN, and MPLS LDP, and then we do configurations on the interface. So we enable MPLS on the interface, MPLS LDP, so that the labels will be distributed on the network. So other configurations remain the same. You need to enable MPLS on the interface, enable MPLS LDP, and MPLS RSVP. And then you also have to enable the BFD. So all the other configurations are the same for all the remaining routers. On the CSGs, we are doing the same. We are configuring the MPLS LSR ID using the loopback 0 IP, and we do MPLS configurations globally, and then we enable on the interfaces. So you have MPLS, all these configurations configured on the interfaces. So with this one in place, we'll now be able to configure services on the network. We'll be able to configure layer 2 services. We'll be able to configure different layer 3 services. We'll be able to implement the BGP, MPLS, VPN for our network, and be able to carry different services using different VPNs. So these are the configuration that you need to apply on the nodes. And once, just to verify that we have this configuration configured, can display current configuration on RSG1. You can see we have MPLS configurations and BFD. We are using LSR ID to be 1.1.1.1, which is the loopback IP. On CSG SAM, we have these configurations in place. So we have MPLS LDP, MPLS TE, and MPLS enable on the interface. So of course, the first command that you need to run is MPLS, so that you enable MPLS on the interface, and then you can specify other commands like MPLS LDP and MPLS RSVP-TE. And these are the global configuration that we do on the CSGs. So one thing that we can perform to verify is to check the LDP sessions established between these nodes. So we can display MPLS LDP sessions. You can see that on RSG2 we have 3 sessions established to these nodes. So we have LDP session to RSG1, we have LDP session to SG3, and we have LDP session to also to SG3. SG2 and SG3, that is, and RSG1. So we have LDP sessions established between these nodes. So on CSG1, we expect 2 LDP sessions. If I run display MPLS LDP session, we have 2 sessions on CSG1, one to SG1 and another one to CSG2. We can display MPLS, LSP, and these are the LSP that we have on this node, the in out, the FEC, and if you have VRF configured, it will also be indicated here. All these are LDP LSPs. Remember, we are using LDP as our signaling protocol. Then we can display MPLS LDP all, display MPLS LSP, bubbles, indicating that we have LSP information. We can see the detail information, and we can see, remember, for LDP we have three for MPLS operation we have three actions. We have push, we have swap, and we have pop. So when a label is assigned, you can see that it will be coming with an action. This one indicates that the label operation should be pop. So the pop operation will be performed here. Then out label, inner label. You can see different types of label. The implicit null, the out label is null. So we have different labels assigned for different connections. And all these will be demonstrated when we are doing service deployment on our network. So on SG4, we can do the same, display MPLS, for example, BFD session. We don't have MPLS BFD session active. Display MPLS label, static available. These are the static available labels for MPLS 16 to 1023. Display MPLS LDP all. Nothing much. Display, let's see, display LDP, no, display MPLS LDP, MPLS LSP. We have already checked MPLS LSP. So these are the MPLS LSPs on this node. Remember, an LSP, the label switching path will be established between different nodes. So as you can see, we have multiple MPLS LSPs on each and every node. So this is how you configure MPLS, and I've mentioned that we have discussed how to configure different protocols on the network, starting with IGP for reachability, BGP for route exchange, and then we now have an additional protocol that will allow us to do multiple services, to deploy different types of services on the underlay network. So these are the configurations. Just to go through them again, you need to enable MPLS on the interfaces, and this is how you do it. MPLS, MPLS TE, MPLS RSVP-TE, MPLS RSVP-TE hello, to enable exchange of hello messages just for maintaining the session, and then MPLS LDP. So if you do a packet capture on this network, we will see that we have packets for different protocols. Just to illustrate that, you can see we have LDP packets coming in, we have ISIS, we have BGP. So we have ISIS that was deployed before, ISIS hello messages, the CSNMP and PSNMP. We have BGP keep alive messages, and now we have LDP messages also coming in. And this one gives you the details of the LDP version 1, the PDU length, LSR ID. We are using the loopback 0. Then you can also see the details of the hello message. So this is it. This is how you deploy MPLS on IPRAN network. So on our subsequent episodes, we'll be discussing how to deploy services on the network. Remember, we have layer 3 services, we have layer 2 services that we need to deploy on our IPRAN network as a service provider. So in our upcoming sessions, we'll be focusing on how to deploy these services so that we can go ahead and continue doing BGP implementation for different applications. Thank you again for watching, and please, if you have any question, feel free to leave it in our comment section. If you have any comment, maybe not a question, you can also feel free to leave it in our comment section, and kindly subscribe to our channel for more upcoming videos. Thank you.